Doing? Are you enjoying the conference so far? Yes? This is not Polish, is it? No, but you understand, yeah? The good news is we speak a common language, which is Java, which is geek. Yes, so we'll be able to communicate very nicely. I'm so thrilled to have you here. As she said, my name is Scott Davis. I run a consultancy in the United States called thirstyhead.com that focuses primarily on Groovy and Grails, Groovy training, Groovy presentations. I come into large organizations and help them formulate their Groovy strategies. How many of you in here write Groovy at this point? Good, a couple of you, yeah. How many of you have done any Grails development? Any? A couple of you, okay, the same ones, that's good, yeah. So for the rest of you, Groovy is a brand new thing, never seen it before, never heard of it, no idea. The other talk was full, so you decided to come here instead, yeah? No. We'll talk a little bit about Groovy in here, we'll talk a little bit about testing using Groovy to test your code. Because as I come into very conservative organizations, very large organizations, many times they say, this Groovy, it's too new, it's too unproven, we can't trust it in production. Does anyone know when Groovy was released? Groovy 1.0? Yeah? It was in December of 2006. December of 2006. Now, Groovy was released, the very first release was back in 2002, 2003. So it's had a very long history, but it's been 1.0 since 2006. There are many large organizations that are using Groovy. Mutual of Omaha is a very conservative insurance company in the United States that has over 70,000 lines of Groovy code in production. There are many organizations, IBM, SAP, Oracle, all have Groovy in their organization. So Groovy is an interesting language because it's a dynamic language for the JVM. We've all been Java programmers for quite some time, right? Yeah? Do you remember when Java used to mean the language and the platform? It was just all kind of mixed up together. We say Java the language, Java virtual machine. It was all kind of interwoven with each other. But now we need to separate those two back out again. There's Java the language, which you compile into bytecode, which runs on Java the platform, the JVM. But it's not just Java the language that you can use to write programs for the JVM. Sun Microsystems, Oracle, right? Yeah, whatever they're named these days. Yeah, supports no less than 5 different languages on the JVM. I'll give you a moment to think. Can you think of languages other than Java that Sun supports, Sun actively supports and promotes for working on the JVM? JRuby, oh, very good. Yes, JRuby, yeah, which is a Ruby implementation. You know, it allows you to take your Ruby code and run it unchanged on the JVM. Very good. JRuby is a great JavaFX, yes, for your graphic design. Jython, I heard someone mention in here as well, which is a Python implementation that runs. So we've got Java, JRuby, Jython, JavaFX. Scala is a very good language. It's not supported by Sun, no, but it is a language that runs on the JVM. The 5th is actually JavaScript. Do you remember when Java 6 was released? They said we now support JavaScript on the JVM as well. So these 5 languages, Java, JavaScript, JavaFX, JRuby, and Jython, are all official Sun supported projects. Now Scala is a very good language, but it's developed outside of Sun. And Groovy is another language that's developed outside of Sun, but still supported on the platform and running. What's interesting about Groovy, and what makes it different than these other languages, is that they are other languages. You can't take a Java class and rename it from .java to .rb and expect JRuby to run it. You can't rename it to .py and expect the Python interpreter to be able to understand this. These are all different languages that run on the JVM. Groovy was written from the ground up to be Java compatible. So much so that I'll get geeky on you for just a moment here. Groovy uses ANTLR as its lexer and parser in order to identify the keywords in there. The Groovy AST abstract syntax tree is based on the Java AST. So it starts with all the keywords, all the symbols, everything that Java has, and Groovy adds its support on top of that. Groovy was written for us, Java developers, who didn't want to learn a different language, but we wanted to bring some new features into the Java language. And so you'll find that Java and Groovy's not meant to be a replacement for Java. Groovy is meant to augment Java. It works very tightly with Java. As a matter of fact, and you'll see this in just a moment, I'm going to do some live coding, that in order to Groovy enable your project, you add a single jar, the Groovy jar, to your class path. And that's all it takes to add Groovy to your project. Now, the reason I'm talking about Groovy in the context of testing here is that a lot of organizations, if they're worried about bringing this new language in, this untested language that they're concerned about, I tell them, why don't we bring it into the testing organization? Why don't we use Groovy to test Java? That's an ideal way for you to learn the language, learn the idiom, learn the syntax, get comfortable with the language in a testing environment, and then only then, when you're comfortable with it, you can bring Groovy in to production. Does that make sense? Yeah. So, let me ask you this now. How many of you are writing unit tests back at your company? Very good, very good. Probably about half of the hands went up, yeah? How many of you feel like you're writing enough unit tests? No hands go. Okay, good, yeah. Most of the time, testing is addressed like this, isn't it? That testing is something that you're supposed to feel bad about because you're not doing enough of it, or you're not doing any of it. This is changing. Testing didn't used to be an important and integral part of the development process, but that's changing. That's changing. Do you remember when Java introduced the assert keyword? Do you remember what version of Java did that? 1.4, yeah. So there was a lot of history in Java before testing was important. But now, testing should be our de facto standard. Testing is something we should just assume. There are many companies that have test coverage, the numbers of lines of code that are affected by unit tests, in the 80, 90, 100% range. Neil Ford, who was speaking here last year with a company called ThoughtWorks, a consultancy, they have 100% code coverage on every project they work in. They will come into an organization and they demand that we will only do pair programming and we will only deliver code that's 100% covered by unit tests. If the company says, no, we can't afford that, we want the production code but not the test code, things like that, ThoughtWorks backs away. They said, we're not going to do development this way. Cisco, very large organization, has a rule of 80% code coverage. They said at least 80% of all of our code needs to have at least some kind of unit test associated with it. I could go on and on, but there's a real change in the industry. There's almost a feeling that it's professionally irresponsible if you don't unit test your code. Now, I'm not trying to make you feel bad. That's not what I want to do here. I don't want to be Darth Vader, yeah? But I want to get you excited about testing, and maybe a language like Groovy will help you get excited about doing something like this. This should not be the way you feel when you're writing unit tests. This should be something that you enjoy, because what it does is it makes you sure that your code is doing what you suggest it's going to do. It's a way to quantify quality. How do you prove that your code is good to your coworkers? Well, it's good. I wrote it, so it must be good, right? Yeah. You know, there's a way that we try to say, no, I've not only written this code, but I'm going to prove to you that this code does what I think it's going to do. Now, there'll still be bugs, of course. You're not guaranteeing that they will be bug-free, but you're making the effort to prove that this code is doing what it says it will do. Again, if you're not feeling this confident about this code, if you're not feeling, you know, that, hey, I can present my code and present the proof that it works, you're kind of doing it the wrong way. Yeah? There are many ways that you can check to see if there's staples left in your stapler. How many of you recommend this method? Right? No, not at all. But these are the kinds of things that come up. If your code is doing financial transactions, how are you going to make sure that you are not losing money in the midst? Are you going to do this? Yeah? If your code has security wrapped around it, that if I log in as an administrator can only do this as opposed to a user, how are you going to test it? Not like this. Yeah? So, let's get in and show you some live coding here. We've got about 20 minutes left. So let's come in here and demonstrate some of this Groovy testing. Now, I'm going to come in here and I'm going to create a new package. Yeah? All right, nothing up my sleeve. Yeah, no, this is all brand new. And let's suggest that we wanted to come in here and create a new car. Automobile, yeah. And so if we were to come in here right now and we didn't have a unit testing mentality, if we weren't thinking about doing test-driven development test first, we might come in and create a car and just off the top of our head say, all right, I think a car has a number of wheels, doesn't it? And I think a car has a make, whether it's a Honda or a Toyota or you know, VW or any of these things like that. And let's see, it has a model year as well. This is a 2004, a 2005, this kind of thing. And we could go on, right? I mean, I could come in here and I could give it a color and I could give it number of doors, but that's probably enough to prove our point. And if I come in now and say, all right, well, I'm going to generate a convenience constructor. Let's see, that looks pretty good like that, right? And I need to come in here and I need to generate some getters and setters. So we'll do some getters and setters out of that. Yeah, all of that. Look at all this code we have, almost 50 lines of code. How am I sure that it works? Well, you know, these are getters and setters. These are nothing that you want to test. This isn't anything. But this is how we get untested code. I immediately now have to go back and write tests to cover all this. It's like eating your vegetables, right? Yeah, no, that's not fun. So what if we take a different approach to this? What if instead of writing all of our code and then being forced to test it after the fact, what if we write our tests first? And I think what we'll end up with is a better modeled code. Because some of these things, getters and setters, right? Can you change the year of the car after it's already been built? Can you change the make of the car? Can you say, oh, I bought a Toyota, but I really wanted a Porsche, so I'll just call set model a Porsche? No, it doesn't work that way, does it? So by writing our tests first, we begin looking at this code, and we begin saying, there might be a better way to accomplish this. So we'll start back like this, but I'll come in, and I'll create a set of unit tests. Again, a new package. Krakow. I've been saying Krakow like an ugly American all this time. Krakow. I'm learning. I'm trainable. You can teach me things. So, I'm sorry? Do you have a test for that? I don't know. No. So I'll come in here right now, and I'll create a car test. Yeah? And I'll say, all right, test create car. How do I want to do this? Is that a valid car? Can we create a car that way? Yeah, I mean, we'll probably say no. I mean, what I'd like to do is I'd like to say I'm driving a Honda 2009. Yeah? You can see by writing the test first, it forces you to think about what's the minimum appreciable way that we can identify this car. And so we come in here and say, all right, so this lets me know that I should probably have a make, a year. Are these things that can be changed after the fact? No, like we said, no, and so they probably ought to be final. Yeah? And my ID is yelling at me and saying, well, if you make them final, well, we definitely need to set them through the constructor. Yeah? So if I come back to this now, say, oh, good, my car test will run. Run. Where are you run? Run. Now. Extends. Test case, yeah? All right. So now, I know, we're going to do this in Groovy. Don't worry, I'm doing this right now. We come in here and now we can say, all right, now I can run this car test. No, test method isn't public. All right, public void. Now it'll run. I guarantee it. No chance at all of failure. Whew, all right, yeah, all right. So this is just the basics of getting started here, just trying to do this. Now in Groovy, I can do the same kind of thing. I can write a test case, only instead of a test case, it's going to be a Groovy test case. So we'll come in here right now and we will say, I want to create a new Groovy class. I'll say, another car test. Extends Groovy test case. Now this is your first time seeing Groovy, and so we'll begin seeing some of the things we can do. First of all, I can come in here. All my methods in Groovy are public unless I specify them otherwise. Another thing I can do is just as before, come in here and do something like this. New car, Toyota, out of 1999. I'm a poor programmer. I don't have a new car. I have a very old car. So we have something like this. Now, we didn't do any asserting before, did we? As a matter of fact, looking at my car, it'd be very hard for me to write any assertions that this worked, wouldn't it? Because I haven't created any getters and setters out of this. Normally, I'd create a getter and setter. But here's one of the things I can do. In Groovy, I can come in here and I can say assert equals 1999. Model year. Now we'll come in here and run this and make sure that this does indeed run, that I wasn't lying to you. No! No such property, model year. Why is that? Because I named it year. Yes. All right. This time, it can't possibly fail. I guarantee it unconditionally. There we go. So this is a somewhat controversial feature in Groovy. What I'm doing is I am actually going in and looking at the private parts. I can see other people's private parts in Groovy. Yeah? There are lots of things that are Java language features that we assume are Java platform features, but in fact are not. In generics, people get very concerned about generics, type erasure in generics. Generics are a language feature. The reason they get type erased is the JVM doesn't have any notion of that. So, generics are a Java language feature, not necessarily a Java platform feature. So Groovy treats the private keyword similarly. Groovy treats that private keyword as a suggestion. But as you can see, we ignore it here. And for testing purposes, this makes it incredibly powerful. If I come into the Groovy shell here very quickly, I'll do something like this. Now, list is a Java util array list. No question about it. And so if I say list.class, one of the things I can do as well is I can say list.class declared fields each. I can begin seeing Java's privates. But again, in Java, we've been able to do this all the time, haven't we? How many of you deal with reflection day to day? Yeah, absolutely. So in Java, you could do this kind of thing. Remember, Groovy is built on top of Java, so it has all of Java's capabilities. So all Groovy is doing here is exposing out the native reflective capabilities of this. So notice that my array list in here has a size element. This is a private element inside of an array list. But if I come in here and I ask for the list.size, I can see there are 3 elements in there. You see where I'm going to do with this, don't you? Yeah. All good programmers like breaking their code. Yeah. So if I come in here and I say list size equals 2, list each, I don't know, Java and Groovy. What? No, remember JavaScript was on there as well? Yeah. Yeah. List size equals 3. There's JavaScript. Yeah. Oh, what happens when I do 4? Oh, you're mean. Yeah? Oh, no. No such element exception. Yeah? So, we can take advantage of this in Groovy as well. What we can do is we can get our classes in an inconsistent state and then assert that this kind of thing is going to happen. It's very hard to do this kind of testing in Java without reflection or making that field protected or somehow giving yourself a backdoor in order to test it. But in Groovy, since we can get at this private stuff without any problems at all, I can model that kind of behavior just as easily in here. Void test break list. Yeah? And so I'll do the same thing I did before. Java, Groovy, JavaScript. I'll immediately say list.size equals 2. And then I'll say list each, println it. So we know that something bad is going to happen now when I run this. Bad things, very bad things. No! Bad things didn't happen. Java and Groovy, I'm having a bad demonstration day. The demonstration gods are very angry with me for some reason. Yeah? That test passed? Of course it did. Yes. All right. But now, do you notice that all my code fails when I want it to pass and passes when I want it to fail? Yeah, that's not good. But here, red bars, red bars, red bars, red bars. There we go. There's the red bar we wanted to see here. No such element exception. Well, what we can do is we can say that when I'm doing this, that it should fail. So I'm saying that I know that this is bad code. I'm expecting it to fail. We're back to our green bars now. Very good, yeah. Yes, absolutely, yes. You can even go so far as to say Java, util, what, no such exception, no such element exception. Yeah, no such element exception in there as well. And getting our unit tests to pass that way. I'm sorry? Put some other exception in there. Println. Oh, I see what you're saying. Yes. Okay, yes. So just to, you don't believe me? I'm crushed. Now. Yeah, today it is, yes. So Java Lang, unsupported operation, yeah? So this is clearly now, this is not going to pass. This is going to fail, but it's going to fail for the proper reason. Should have failed with an exception of type, unsupported exception. Instead got that, yeah? Yeah, very good question. So we could go on and on with just looking at unit testing in here, but I wanted to show you two other things very briefly, and I know we only have about 10 minutes left, a little bit less. So we'll talk briefly about behavior-driven development. Are any of you doing BDD, behavior-driven development, at all in here? You heard about, okay, a couple, yeah. One hand goes up very high, that's good, yeah. Are you a Ruby developer? No, it's very popular in the Ruby community. There are lots of languages, RSpec and Cucumber, that do this. Again, this is fairly new to the Java community, but I'm beginning to do this in a lot of my clients, and they're very excited about it. This is what we think we think all the world as programmers is wearing this t-shirt, right? We think all the world loves hearing us talking about which exception is going to be thrown and our polymorphic capabilities. People don't understand that. They hear blah, 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 blah. And especially your users don't want you to talk nerdy to them. Your users just want to talk to them. Your users want to be able to say, hey, when this happens, I want this to occur. When that happens, I want that to occur. And so what EasyB is, a behavior-driven development framework written in Groovy, but again, use it to test your Java classes. It allows you to do the same kind of tests, but started to say plain English, but that wouldn't be good. You don't have to use English, no. But I mean in the language of your end users, not in the language of a developer. So when your user says something like this, I need to import from iCalendar, I need to import from Outlook. I mean, this is a typical user story that comes in. This is what your code can look like. This is all of EasyB right here. It has the keywords scenario, given, when, and then. But it also supports and, yeah? But other than that, this is the language. It's a very tiny framework, but you can see what it's doing. Given that I have a saved iCal file, when I load it, I should see the events. These are all closures, when, then, and scenario, just like that should fail closure. And what I'm able to do in these closures is write the code that proves that this stuff happens. But what's really nice is your user sees their words right next to the code that's exercising their words. So if I come in here, I'll pull up an existing one of these. When I create a car, yeah, and this is obviously a different car, that's okay. This is a talk that I did in Redmond, Washington. Then I need to know what the make is, and I need to know what the model is, and I need to know what the year is. And so you can see we're doing the same thing we were doing before, car make, car model, car year, but now EasyB is adding this should be keyword in it as well, which lets these particular tests pass. If I come in to my Ant build and run EasyB, what I'll get, oh no, fails, no. We'll pull up the report anyway and we'll see what failed. If I come in, there we go. And I come into what? I come into the build directory. There we go, my BDD test reports right here. I have test report, much like JUnit, but a test report that shows me which tests have failed, which tests are pending, which tests have passed. And as I come in here and take a look, I can see that this test is pending. I'm testing subtraction. This test passed, pending, pending, pending. And this is what failed right in here. Yeah? So this tool makes it very easy for you to sit down with an end user as we're going along here and be able to say something like this. Okay, so I can come in, create a new file. We come in and do something, cookiestory.groovy. Yeah. That's a perfectly valid easy B story right there. That's what's going to show up as pending. Okay, so what else do we do? When I print out my monthly report, then and we can go from there. So this is a tool that I use as a contractor, sitting down with clients. When they're explaining these kinds of things, I can usually keep up with them fairly quickly, and I'm just gathering these pending requirements, pending, pending, pending. Of course, at the very start of the project, you're all pending. But then when your burn down chart starts coming down like this, you begin seeing that, okay, all of these pending stories start getting satisfied, start getting resolved, And again, in each case, you start with this, and then you add the closures and fill in the code that makes these tests pass. So the very last thing I want to talk to you about here is using Groovy for mock testing. How many of you do mock tests in your organization? Yeah? Oh, good. A lot of you. What do you use? Mockito? Easy Mock? Yeah? Any others? JMock, yeah, very good. All very good libraries. We know what these mocking libraries are for, right? They're to protect you from having to have a database up and running. They're protecting you from having a web services up and running. All these external resources, you want to mock out those resources so your unit tests will run very, very quickly. Who is this? Who? Mock Elvis, exactly, yes. This is someone that has all the characteristics of Elvis, clearly not really Elvis. But he was recognizable enough that you could see. Who is Mock Elvis with? Mock Marilyn, yes, we have Mock Elvis and Mock Marilyn. These are what your mock classes should be like. Just enough to be recognizable, but you don't have to re-implement an entire database or an entire set of web services or anything like that. And so Gmock is a library that was actually inspired by EasyMock. So if you have these libraries and you're using them, I encourage you to continue using them. But what Gmock does is it uses these closures, once again, very, very effectively. So we can begin doing these kinds of things, saying when someone calls load, it should return apples. When someone calls this, it should do that. I know that we ran short of time due to other presenters running long, so I apologize about that. But Gmock has a lot of very good documentation on the interweb. Yeah. So we end up looking at a mock test that looks like this. And again, if you use EasyMock especially, you'll recognize this. But you put things in a play closure. So we come in here right now. This is a very powerful one right here. When I say that someone is going to call new file with a constructor that has this in it, when they call get name, I want it to return this. And so you can see you're setting up your expectations here. And inside of this play block, you have your mocking. That's Mock Elvis and Mock Marilyn right there. So a great set of online documentation right here. As a matter of fact, they have a section in this document that says, this is how you would do it in EasyMock, and this is how you would do it in Gmock right here, and so you can do some side-by-side comparisons. But in a nutshell here, Groovy, hopefully you've gotten just a taste of what you have. It's a language that is not meant to replace Java. It's meant to complement Java. You saw that when I created that list, it was a Java util list. You saw that when I created my car, the car was very clearly in Java, but I was using Groovy to test these things. So I have an ongoing series of articles with IBM Developer Works called Practically Groovy. I have another set called Mastering Grails as well. Good resources for you to learn about using Groovy in these contexts. I know Anna as well, the organizer of the conference, has a couple of my books, Groovy Recipes. I think she's going to give away by the end of the conference as well. So hopefully this gave you just a taste of what it's like using Groovy. Did you enjoy yourself? Yes, I did as well. Thank you very much for your time and your attention.
Zapraszam teraz na krótką przerwę. Następny wykład rozpocznie się o 16:35.
I give you a extra large size T-shirt.
Oh, yeah.
If you want smaller or bigger one, I will change. Okay.
Oh, wonderful.
Extra large is okay.
Yeah, do you have a 2X? Or just
do you
X?
want- I have-
If you have a 2X, yeah.
Correct.